Hello and welcome to Microchip live stream today. I am Xavier Bignale. I'll be your host for this session. Today we're going to focus on the secure authentication topic for LoRa network. So today I have two experts with me. One a very close colleague of mine, Abhi, and we have a very special guest, huge experts in the LoRa community, Johan Stocking. Can you introduce yourself for the viewers?
Yeah, so my name is Abhinay Veneturumilli. I am Applications Manager for Secure Products Group, and again, I work very closely with Xavier.
Hi, my name is Johan Stocking. I am CTO and co-founder of the Things Industries.
Very good. So before we start talking about the whole topic, I would like to give the presentation to the studio. I think you guys have a few words for the crowd.
Yeah, thanks, Xavier. Yeah, my name is Matt Dickens. For those of you that have seen me before, sometimes I'm out there, sometimes I'm back here. I'm here with our newest member of the well, not newest member of the team. I guess you've been on once or twice before.
Once before.
Clifford is making his big debut this year.
I'm filling in for Wayne. I'm very excited to be your co-pilot for this live stream.
Yeah, so buckle up. It's going to be a good ride. Before we get started, a couple quick notes. First of all, if you want to comment and chat, whether you want to give a shout out to Clifford's great hair or you want to ask a question about the security in the LoRa products, feel free to do that in the chat, or you can email us at livestream@microchip.com.
Yep.
And that will be two great ways to ask us questions. We'll be monitoring both of those things, and we'll make sure to ask your questions if they are going to be relevant and time sensitive to what we're talking about today. And if not, feel free to still ask us questions, but you can email us at that livestream@microchip.com, and we can make sure that if it's a longer answer or there needs to be more information, we can follow up with you after the live stream and make sure that we get that information into your hands, because we're here to help, and that's what this live stream is all about.
And real quick, we will be giving some prizes away. So
That's
those
right.
of you that do comment and engage, we'll be sure to list names at the very end. So
Yeah,
we'll be giving away
the SAM-R34 development board, and we'll be giving away some crypto authentication sockets as well.
Cool.
So, and if you don't know what those are, stay tuned. You're in the right place, because we're going to talk about those today.
Yep.
So with that, Xavier, why don't you tell us a little bit more about what we are working on today?
All right, so before we start into the security topic, to help our viewers, I'd like Abhi and Johan to paint us a picture of what LoRa is, where do you see LoRa in which markets. Can you guys help us with that?
Yeah, so LoRa is a modulation to get data through the air over long range using very little power. So it's just a way to transmit data through the air. When I say low power, it is kind of in the order of magnitude of 25 milliwatts. So that's really designed for battery-driven applications. Long range goes in the miles. So we see, for example, in Europe, 10, 15 kilometers in outside of cities, but also within cities, a few hundred meters is normal. LoRaWAN is a software protocol that is on top of LoRa, and LoRaWAN is about what the messages look like and how the security model works, and all kinds of network layer things that are in there, because devices that are on a LoRaWAN network, they don't have an internet connection. So it's not like, for example, devices that join a Wi-Fi network, they have internet. So you can make use of all the standard protocols, Internet Protocol, TCP, but there's nothing like that in LoRa devices. So there is a MAC layer, Media Access Control layer in LoRaWAN, that's really essential part of the network. Okay. And so if we look at the architecture on the slide, you see what a LoRaWAN typically looks like. So you have devices, and they can be in all kinds of environments and industries. And they are being covered by gateways, and gateways they have an internet backhaul. So what gateways really do is they decouple LoRa traffic from internet. And then in the cloud you have a network server, and that is where the gateways are connected to. And a network server does the server side of the LoRaWAN protocol. I have a gateway here, just to give you an idea of what a gateway looks like. This is an indoor gateway. This is one of our products. So you can put this in a power outlet, and this allows you to cover a building or a few floors for LoRaWAN devices.
Okay, very good. So if I summarize a little bit, you have an application server, a network server, gateway, and nodes. What type of use cases do you see in the LoRa industry?
Yeah, all kinds of use cases. So we have users and customers in all different kinds of industries. We see customers that are replacing Wi-Fi and BLE with LoRa because of the low power characteristics or long range, but it also opens up a whole class of new use cases that were not possible before. So one of the great examples that we typically use is this mousetrap. This is a LoRa connected mousetrap, and this is actually designed by a pest control company that before had to send somebody in a car to abandoned buildings to check all the mousetraps every 24 hours. And this device allows you to turn that whole process around and make it push-based. So this is a very simple example with a very clear business case. But we also have a lot of industrial use cases, such as cold chain for compliancy. So we have customers that track medication that need to stay cool in a certain temperature. But we also have customers that synchronize clocks in train stations. So all kinds of use cases, and you really want to make sure that everything goes right and that is end-to-end secured.
Okay. Yeah, I think there are a lot of other use cases that we are also seeing in the utilities, for example, the gas meters, water meters, smart cities. Smart cities is a huge thing where the smart buildings, smart parking, sensors, things that would not have happened before without LoRa, because LoRa brings two competing things together. One is the long range, and with long range, typically one would expect more power consumption. But in the LoRa modulation, as what Johan mentioned, it kind of provides both benefits. You get the range; it's 15 kilometers, as he pointed out, but you get the range battery for years of battery life. The mousetrap example probably is going to live for the rest of the life of the building. For that, with one coin cell battery, because the amount of power consumption to communicate, even though it's that range, is extremely low.
Okay. Right. So let's help the viewer to understand the technology providers. So you mentioned, again, you have an application server, you have a network server, you've got gateway and edge node. You just showed us a gateway that you guys are providing. So who is TTI? What is TTI providing? What is TTI? What are those three letters together? Can you talk us about your company?
Yeah, so we started 4 years ago with the Things Network, and that is a developer community. That's a community network. And we started off as an experiment to cover the city of Amsterdam, where I'm from, in 4 weeks with 10 gateways spread around the city. And we opened that model up, and we invited the LoRaWAN developer community around the world to do the same and to buy gateways like these or other gateways and to install them somewhere and to connect them to the Things Network. And so that is now, that has grown to become the biggest global LoRaWAN network with 8,500 gateways worldwide. But that is a free network. It's community driven. There is no service level agreement. It's just for R&D and a lot of use cases without a clear business model. And next to that, we saw some demand from companies that wanted to run private networks and they needed a service level agreement, and they wanted really their own network. And that is really a great feature about LoRa, is that you can have public networks, and we see that also in Europe primarily, traditional telecom operators that deploy public LoRa networks. Just like the Things Network is a public network, but it can also be used the same technology for private networks. And that is where companies operate and own their own networks. And that is what we offer with the Things Industries. So TTN is the Things Network, TTI is the Things Industries.
Okay, very good. So you provide everything on the cloud infrastructure. If we want to simplify the terms, what do we provide at Microchip?
So there is a question, I think, but
we'll take the question
after. All right. So Microchip also is very involved in the LoRa Alliance. We are one of the founding members of the LoRa Alliance, and we actually have the very first LoRa certified wireless module that has been now, I think, one of the golden units that LoRa Alliance uses for certifying other products and gateways. And we now have industry's lowest power system in package, that is a 32-bit microcontroller with LoRa transceiver. And we also have software stacks that we develop, maintain, and support. And on top of very strong portfolio of wireless devices, we are also focusing heavily on security to make sure it is helping the LoRa platform and LoRa communication protocol that much more secure, and we will talk a little bit more about it today.
Perfect. Matt, do you want to toss us the question?
Hey Xavier, yeah, so we have a great question from Dick Mincher, and he's asking, is there a good developer forum for covering the ATECC608, so the 608, 508 devices? So like developer forum or general help or places that people can go to get more information once this live stream's over. Just kind of a quick plug for that, I guess.
Yeah, so we will again discuss some of the solutions as part of the live stream where we will provide more details, and on top of that we do have a very active GitHub repo community where we interact with users in that area, and we also have a lot of support forums on Microchip, and with TTI we are releasing solutions that we will talk a little bit more, which I hope will provide more details on that.
Okay, so we've talked about LoRa as a whole. Let's try to dive into the security topic in itself. So can you give us, so we see both sides of the equation. We see the edge nodes, the back end. Can you guide us? I'm going to start with Abby. Can you guide us with the notions of security, and especially about authentication around the LoRa infrastructure? Can you tell us about it?
As we pointed out, the use cases, there are multiple types of use cases that, and most of those use cases really rely on a strong security as part of the IoT or Internet of Things. And the good thing is LoRa specification really focused heavily on making sure that it has very strong security protocols. So it uses a very standard AES 128 key, which is NIST approved and NIST certified. And what that means is it is based off a symmetric key. So if you can maybe connect to the slide. So the way that security is built on top of LoRa is based on symmetric key architecture. So the edge devices, the sensors that Johan was talking about, and the application and the network servers, they both share the same key. And by sharing the same key, you can not only authenticate, because you can make sure that the devices are communicating and nobody else is impersonating that device, but you can also encrypt the data so that no eavesdropper can either look at the data or would be able to tamper the data. So LoRa in general has taken a pretty good focus in terms of making sure security is good from a cryptographic perspective. And we'll talk a little bit about some other challenges which are outside the scope of the specification, but more in terms of the logistics.
Do you want to add anything to that, Johan?
Yeah, so on the server side, indeed, it's a symmetric crypto. So if we go back to the slide, you see there on the right the application server and network server. And that is where, these are our products. So this is what we built. And there are other companies in the industry that also built these products. And they are standard components in the LoRaWAN architecture. And these also need to have the keys. So if you provision devices, you need a way to securely provision these keys in the network server or application server. And that is where the challenges arise, and this is what we are addressing in this solution, but we come to that.
Okay. So now imagine a customer, he's got his LoRa nodes, his LoRa product already done. So he's got the radio, micro, he chose the sensors, he's already pumping data into a backend. And we've heard in the industry scale issues, because there are several things happening across the globe where, for example, let's take Europe and even some initiative in the US we start to see legislations popping up, right? In the UK, GDPR all over Europe, the US or with the, I think it's California with the SB 327 is reinforcing some of the practices of, trying to reinforce practices of securing credential protection. And then on top of that, we have those legislations. And now that customer is selling this product to, let's say, a hotel chain. That hotel chain, obviously, it's global. They're going to be in Asia, in Europe, and somewhere in America, South America. And now you have this entire, now we got a gap, right? The network, the global aspect of the situation, and the legislation. I mean, can you guys help those customers? How do you guys help those customers from a network standpoint and a device standpoint?
Yeah, so I think that's a very good question. So as I mentioned earlier, LoRa takes care of certain aspects of security, which is the standards, what kind of standards need to be implemented, what kind of communication protocol it needs to be implemented. But there are things outside the scope of the specification, like how are the keys generated? Key is fundamentally identifying that device and nobody else but that device. So everybody knows how AES-128 works, but how one would know that this device is trustable, and identifiable is based on the 128 bits. That's it. And the key challenge that we typically see is how do you generate these keys? How do you provision these keys? How do you, when at the time of development, engineers typically develop in a prototype or proof of concept, and they develop the keys by putting some dummy keys in their code and do it. But once they move into production, there is a huge logistic challenge that they need to take care of. And in the example that you brought out, where the hotel, a sensor device, for example, a cold chain device, is now getting a contract with one of the hotel chains, and the hotel chain is spread across multiple geographies, where multiple different network operators are performing the LoRa networks. How do you scale is a huge challenge that one would have to think through. I don't know if you want to.
Yeah, that's right. So, and if you look at the overview here, then you have on the right side also the application server and network server. And what is also good to mention here is that since you have all kinds of LoRaWAN networks, it's not just a publicly commercially operated network, it could also be a private network, that once you provision keys in a network, the keys are there, and the keys, the root keys of the device are there. So you really have to trust that network server and the application server with those root keys. So that is really a challenge, where LoRaWAN fortunately provides for a concept called a joint server, and that is a trusted third party, which the device maker can use to securely provision the devices, and then any network or application server further in the lifetime of the device can get session keys to join the network.
Okay, so if I summarize the challenges that you guys have talked about based on that scenario, challenge of protecting the trust from one end to the other on a symmetric scheme. On the device side, how do we do that? That could be complex, and the complexity trigger another notion, which it's kind of weird, and as we talk about security, is manufacturing. It's that there is a manufacturing. It looks like there is a supply chain challenge that needs to be addressed. And then same thing, how do we implement the trust equally in the back end, right? Yeah. So those are all the challenge that our customers will be facing.
Yeah. One thing that I probably did not impress upon earlier is the whole concept of moving these into the contract manufacturing world, and things that we typically ignore in that aspect is, an engineer would develop the solution and then move it to the production side, and production side, somebody in other part of the world maybe is building the product, a contract manufacturer, and on a monthly basis, if they do 20,000 devices, 20,000 cold chain sensors, somebody is manufacturing. All of those 20,000 every single month, as the, if that's the forecast or the ramp, have to have unique keys. All the 20,000 have to be provisioned with unique keys. Somebody has to generate those keys. Somebody has to load those keys into the device, which means either the company who owns the product would generate the keys, then send those keys to the contract manufacturer, which means contract manufacturer, before loading the keys into each of the devices, has complete visibility into the entire key database. The employees of the company who actually generated the keys have the complete visibility of the entire keys, and tomorrow they may leave the company. And in between, there could be multiple other stages and multiple recipients of that key material on a monthly basis. That could be a huge vulnerability at scale, which many times we ignore. We look at it from a cryptographic algorithm. Okay, it's AES-128, it's perfect, but we don't really focus on the logistics and supply chain. But unfortunately, that is where there are a lot of shortcuts that are being done today, where people end up using the same key across the entire product line. For example, if I do 50,000 devices, all 50,000 end up, we have actually met with a few customers where they had same key across all 50,000 devices, rather than individual unique keys. And so those are the shortcuts, unfortunately, that developers are using, and because of that, those devices are prone to vulnerability in future.
Yeah, for the sake of knowing of a better option. I see we have a question. Matt and Clifford?
Yeah, Xavier, we have a couple questions actually. So we've had some good questions getting asked on the chat. I think we're not going to cover all of them right now because some of the stuff we're going to talk about later. So Isaac, specifically to your question about integrating the ATECC608 into the flow of the system, I think that's actually something we're going to talk about a little bit later in the live stream as we move on. So definitely going to get to that question, but we'll hold off on that one. But we've also got another question that I think this makes sense to answer now. But there's a particular user that's trying to create like a secure kill switch for an RF control, and so they want to put a secure element on that switch. And they were specifically asking, what's like the max frequency that the ATECC608's GPIO can run at? I'm assuming referring to the RF and stuff like that.
Okay, so the ECC608, we have not introduced the product yet, but it is a secure element. And so that chip by itself is not a radio frequency or wireless chip. It is a secure element that stores security keys, and it can communicate to the microcontroller at 400 kilohertz on I2C bus, or even up to 1 megahertz. And the actual communication to the wireless is done by the microcontroller and the wireless transceiver. The secure element really doesn't fall into that wireless portion of the communication.
Awesome. Yeah, no, I think that's a great clarification, because I think for some people, especially if you don't have as much experience with this, still separating what the different chips are doing in our head can be really important. So great clarification on that. Thanks, Avi.
Sure.
Okay, one more question?
I think we're good. Like I said, I think we're going to cover the other questions that are getting asked a little bit later, so I'll let you guys keep moving.
So we left it at, getting keys into places, right? Let me ask you, Johan, if you've seen countless customers that you interface directly, how do they get the keys today?
Yeah, so that is really a reflection of what Abi just explained in the supply chain with the physical distributors, devices that go travel around the world while they are assembled. We see that also in the cloud, where at some point these root keys need to get provisioned in a network or in the application server. And so what happens sometimes is that this is a great example of a device that I ordered just for testing, is that I got a piece of paper sent along the device with the keys. And so this is not only very impractical to enter, to type this hexadecimal keys into the network server, but also these keys are exposed, like literally exposed. And everyone who has had access to this paper along the way can actually read the data of this device. And the keys are really part of the identity of the device, because these are the root keys that you cannot change, or you cannot change easily without a solution for that. So, so we see keys distributed on paper, keys that are in Excel files that are sent along an email attachment. They are forever in some email archive. People leave companies, indeed. And we also see, indeed, like Abi said, a lot of reuse of the same keys for a whole batch of devices. We also see very good practices. So we also see, a lot of device makers that are using unique keys per device, but still there is a challenge to securely transfer keys from the device maker to the end user, because there are a lot of steps in between. Distributors, sometimes the LoRa part is only a piece of the final device. It gets inserted in something bigger, and so it gets assembled and bigger throughout the supply chain, and that's very complex.
I see how you, now both of you are emphasizing the notion of logistics, not just through supply chain, but also how to provision those keys in both hands. I'm actually quite impressed by paper. So you're telling us that if I have 10,000 units, I receive a paper for 10,000 units.
Yeah.
That's okay.
Well,
I'm going to leave it
that's-
there.
yeah.
I'm going to leave it there.
This is the worst example, though. I mean, this is not state of art, but
Yeah.
this happens. This
No, I
happens,
mean,
yeah.
people think, making it a barcode instead of a,
Yeah.
entry may be better,
Yeah.
but really it's still, easily legible. I mean, people can easily read barcodes and
Yeah.
figure it out. It may help from a
Yeah.
supply chain, efficiency, where I can quickly do a barcode scan,
Yeah.
but your keys are still exposed. And,
Right.
people and attackers and hackers, they know how to read a barcode.
Yeah.
They know how to get the parts.
I can't imagine how manual it is for that customers, actually. Interesting. So, okay, we've talked about the challenges. Now, talk to me about a solution, right? How about that? So what has been happening in the past few months? I know you guys have been working together a lot. I've seen you very closely working together. What kind of solution do you propose to address this logistic problem and that provisioning problem on both sides? What are you guys having?
Yeah, so certainly we have been working very closely on this problem, and we have looked into it pretty deep. We looked at it from different personas. Is it the edge manufacturing, device manufacturing? What are the complexities involved at that stage? What is the complexities at contract manufacturer? If somebody is loading a unique key, then they have to, traditionally, if it's a microcontroller with different keys, they either have to go and set up a database to go and grab different keys, or they have to reflash every time with a new key. It's a challenge on the contract manufacturer side. Of course, there is a lot of vulnerabilities in the process, but also complexity involved. We looked at it from distribution and supply chain logistics. We looked at it from network servers and application servers, how do they get the keys?
Mm-hmm.
And also we looked at it from how can we keep the whole ecosystem agnostic and easy to switch from one network to a different network. So we looked at it from a holistic point of view. And now we are glad to say that we now have a solution that really is end-to-end secure, end-to-end easy to implement, and also agnostic, where customers can easily switch from one network to the other. So
Okay.
if you can maybe go back to the slide. Really what we have done from Microchip side is we have worked closely with the Things Industries to come up with a pre-provisioned secure element. And what that means is that customers no longer have to really worry about key generation, key storage, key sharing to the contract manufacturers. We have taken care of all of that, and so customers just go online and can procure a specific part number that would be based on the 608, and we will share that in the footer later, the exact part number. And once the customers can get that, they can just put it on their board. Their experience as part of their development and prototype, and as they migrate and move to the pilot order and production, would be identical. They don't have to take any new steps in terms of making it more robust or more secure, and whatever they have implemented at the prototype stage is identical for them to move forward.
Okay.
And maybe Johan can comment on the network side, what we have done.
Okay.
Yeah. So if you bring up the slide again, so on the right side you see the joint server, and that is really the trusted third party. So that is where the devices can get activated by any LoRaWAN network. So the joint server is really a part of the LoRaWAN specification, and it also implements these specifications. And it allows for activating devices on LoRaWAN networks. So when a device shows up, it sends a join request, for example. So when it gets powered on, it sends a message called a join request. A gateway receives the message, a gateway forwards it to the network server, and the network server doesn't know the keys of the device. But it goes, as part of the join request, there is an identifier to the join server. So the network server looks up the join server and basically requests the join server to activate the device on the network. Mm-hmm. But it's a join server that holds the root keys. It doesn't expose them to the network server. And also the session keys for that particular device session are only sent to the network that the owner of the device chose to activate the device on. So that allows for, it's kind of decoupling the activation of the device, which happens and stays in the joint server, from where the device is actually sending telemetry and interacting with the network.
Okay. I see we have a question. I'd like to ask one more question to Abhi and Johan before So there is, I think we have a missing piece there. So what do we ship when someone order, Abhi? We ship a device,
Yes.
but how do we reconcile with that identifier?
Yeah, so the key point here is when we ship the products which are pre-provisioned, we also ship or we also provide something called a manifest file. A manifest file is nothing but a list of identifiers. If I ship 5,000 devices to you, you mentioned earlier an example of in device manufacturer for cold chain for hotel, chain that you want to sell. When you order the product, then what we do is you get 5,000 devices from us, and then 5,000 device identifiers that you can download for that order, and only you will be getting that order, that file. That file still doesn't hold any keys, any secrets. It is just identifiers, and then that is the file that you will be able to claim the devices with the TTI's network joint service.
So I want to insist on that. How critical the information inside that manifest. If say that manifest land into somebody else's desk,
that's no big deal.
Why?
So because the manifest is nothing but IDs.
Okay.
It's not keys. The keys are the ones that are to be securely provisioned and properly stored. An ID is just like a serial number. Identifiers by themselves really don't have any value, except for making sure that TTI knows and that these devices are owned by the by you, and by that they can recalculate the keys on their side, and that way there is never a key exchange at any point between any party, really the device manufacturer, the contract manufacturer, distributor, value-added service company. At any part of the journey, they would never have to really see the key or upload the key, and everything is done by the manifest file.
Okay. Maybe we can pick up the question.
Yeah, Xavier, thank you. We have a couple questions. One that I think is going to more of a clarification question than anything. But Dimitris, the actual question was, is this join server an option, or can we also program keys ourselves? I think in that question, almost like the quick question would be, like, when you're saying key, what are you actually referring to specifically when you talk about key? And is that something that can be programmed manually into a device, or is that just there automatically? Or when you say key, what are you actually referring to?
Yeah, that's a great question. So when we refer to the key, is the LoRaWAN root key, and the root key is a AES 128-bit key in LoRaWAN 1.1, which we also support with this solution. Actually, there is a pair of these keys, and they need to stay secure. But so as Abhi mentioned, there is no provisioning of keys required in this solution. These secure elements are already provisioned. So you can, as part of your assembly line, you can actually put a new key in the secure element. But the great benefit of this solution is that you don't have to, because we already have this joint server that you can use without touching the device.
Okay. I want to go back to where you guys left it. So, Abhi, you were talking about that manifest that has an identifier. Johan, you talk about an identifier too, right?
Yeah.
So I start to see the connection. So if I understand, what I get from Microchip is a device pre-provisioned with a manifest. Where do I get that manifest from?
From the e-commerce. So the way it works is, you procure the part. As I said, there's a specific part number that you would get for pre-provisioned TTI joint service. So you get that part. Let's say you order, as I said, 5,000 devices. When we ship the 5,000 devices, then you will have the website where you place the order on the e-commerce website of Microchip, and you can actually download. We will provide a download option, and you can download the file.
So what is that file? Is that 5,000 file, one for each devices?
Yes.
Or
yes, it's one file that has all the device details or identifiers of those 5,000 devices that were shipped to you. And you would log into the e-commerce site where you ordered the part, and then you download the file. And as I said, the file doesn't have any secrets, so I want to make sure you clearly understand that. And then you go and log into the TTI's joint service, and you upload it or claim it, and that way TTI would know exactly the device manufacturer, Xavier's, has these 5,000 devices. And then TTI would then go in the back end and recalculate or rebuild the keys I think earlier the question was, what is this key? It's nothing but think of 128 bits of ones and zeros.
Yeah.
And so you really get, but that key is very important. It is a primary identifier of the device. And so TTI would then generate that key on its side and make sure that the two devices can communicate.
So, Johan, I got manifest. I'm ready to upload that manifest to your environment. Describe us this experience.
Yeah, so actually we target two types. There are two types of device makers, really. So we have device makers that operate, that also use their own devices. So they build devices for themselves. And a great example is, for example, a real estate company that builds their own devices for monitoring meeting room occupancy or desk presence. And so they can claim the devices, but they can also at that point choose that they want to use their own private LoRaWAN network. So that is quite easy. The more challenging is where you have device makers that build off-the-shelf devices. So for example, this is a generic node, this is a product that we built, and this can be used for all kinds of use cases. But we don't know on what network this device will show up. So if we as a device maker claim these secure elements in here, we only claim basically as a device maker at that point ownership of these secure elements until we sold them as a device maker to distributors. But there can be many distributors. Then you have the end customer that needs to claim the device to actually at that point onboard the device on the network. So only at the very last step there is the network selection. So there are two parts of claiming. The first is where the device maker claims ownership of the secure elements with a manifest file, and the second is where the end customer onboards the device on the network they want to use.
Okay. Thanks, Johan. See, we have another question.
Hey Xavier, yeah, we actually got a really good question just popped up that I wanted to ask. So Paul Hayes asks, if someone gets a hold of my manifest file, what stops them from contacting the join server and pretending to be my device? Is there a secret key preloaded into the secure element that stops this?
So no. So the way it works is that the manifest file, as Abby explained, doesn't contain any secrets. It's just a list of pointers. And the first user that claimed these secure elements, they own the secure elements in the join server. So it's a first come, first serve. So it's the only thing that you need to take care of is that if you log in to, you don't share your login details of the Microchip purchasing portal with other people, so they can access the file before you did. But that's just part of normal purchasing devices. So you go into the portal, you download the file, you upload it in the TTI join server, and then the devices stay in your account. After that, nobody else can use the same manifest again to claim the devices.
Okay. So if I summarize the whole situation here, if I go back to the customer who's providing devices to the hotel chain, what you're saying is I've got trust in the backend, trust in the edge node, I have a pairing with the join server, and then that's those hotel chain, you don't know honestly which network they're going to run on. And I think if I understood correctly from you, that's one of the value where the join server can run on any network all across the globe, basically.
Right.
Can you just give a few more details?
So this comes back really at one of the most powerful things about LoRa is that you can have public and private networks. And so if you build a device as a device maker, you don't know on what network the device ends up. And you also don't know if that network has a roaming contract. So if I go with my cell phone abroad, then I'm sure it works, right? So, but with LoRaWAN devices, there are so many different private networks that you as a device maker don't want to build a SKU for each and every network where the device may go. So the way it works is that the join server, the device maker, can provide a way for their users to claim the devices and select which network they want to use. And typically that goes by a QR code, or it can be any other mechanism, can be fully automated as well. So this is a good example. For example, on the mousetrap, there's a QR code here, And the end user can just say, okay, this is my device, I scan it with my app, and that way you claim ownership of the device, and then you can select which network you want to use. And this could be, again, it could be a publicly operated network by a telecom operator, but it can also be your own private network.
Okay.
Yeah, I think in the example that again you brought out, maybe this could be for any kind of an example or use case, but the hotel chain example, if that sensor is that cold chain sensor, and you are the device manufacturer of that cold chain sensor, when that particular product is being built in your contract manufacturing facility, you don't know where that final product will end up in. Is it going to be ending up in Ohio, in other part of US, or is it going to be in totally a different part of the country? You have no idea at the time when that particular sensor is being manufactured. And the challenge is, as Johan mentioned, there are a lot of LoRa network operators, some public, some private, and the operator that is running in one part of the state or one part of the country may not be available in other parts. And so as a device manufacturer, you also need to understand that I just can't have a product line for Ohio company. I can't have a product line for this other network. I want one product that can support all geographies, all hotels, for example. In that case, what the joint service with this program would help is the first claiming process. When you get the product as a sensor company, you would claim the devices and say that those devices are yours, the cold chain sensor products.
Yeah.
The second step of the claiming process, which Johan mentioned, is when you shipped these cold chain sensor products to 5 hotels in 5 parts of the world, each hotel would have to connect to its own LoRa network. That's the second part of the claiming. And that is where the QR code will help the hotel chain to say, okay, I just got this sensor, and I want this to connect to my network, which is in that region. And the second part of the claiming will take care of that portion.
Okay. Thanks for the precision. That's actually, I think, very, very helpful. I want to go back to actually security. Johan, I've got a question for you. What's that joint server looking like? I mean, what is it from a security standpoint?
Yeah, so it is a cloud service, and it is implementing these LoRaWAN backend interfaces for the joint flow. So any LoRaWAN network server that is LoRaWAN compliant can use the joint server to activate devices. And so the joint server is a cloud service. It is actually quite simple, and it is backed by a hardware secure module where it stores the root keys of the devices. Okay. So it's really designed, and it's a trusted third party, really. So it's not involved in any traffic or in any telemetry or any network layer stuff. It's only used for device activation. Okay.
Here's a trick question for you. Assume someone doesn't want to use the TTI joint server.
Yeah.
What are the options?
Yeah. So there are actually 2 things to this, which is really good. So one is indeed a transfer of ownership. Which is, for example, if you sell your device to somebody else, or if you have all kinds of sensors in your smart building and you sell the building, how do you securely transfer ownership of devices? So the way that works is that you can make the QR code valid again for claiming, for example, from a certain period on. So if you make and then somebody who scans a QR code can actually claim ownership of the device. And at that point, if it's the first time the device gets claimed or further out in the lifetime, at any point you can not only say which network you want to use, but also if you want to change joint server. And that is a new technology that is part of the LoRaWAN specification. It's getting part of the new specification in LoRaWAN for so-called repersonalization of the device. So there's a lot of technical details to it. I won't go into the details. But the way it works is that when the device activates on the TTI joint server, and the joint server knows that there is a request for changing to a different joint server, the joint server gives an instruction to the end device with information to the new joint server, and then the device activates on the new joint server. So you don't have to touch the device. You don't have to physically go there, put new keys in there. And there are actually new root keys generated in that procedure.
That's the key point. The new root keys are generated, so TTI would not know what the new keys are. And so you can securely transition over from one join service to other. And we have, as in the pre-provisioned device, we have put all the hooks in place to be able to do that as well.
Yeah.
Okay. Let me try to do a big recap and correct me if I mess it up. So I have a device, I have a gateway, I have a network application, and our join servers. Within a join server, I have one symmetric key, corresponding symmetric keys in the edge node, right? We need to do a first claiming of the device into the join server to claim the ownership. That's one claim. And now, when I'm ready to ship my devices, we need to be able to tell that device will belong to a network at any point of time after its release. That's where you use the QR code. Now the device joined the network of choice by the customer. I'm pretty much done after that, right?
Yeah, that's it.
Yep,
Cool.
that's it.
Well, let's reverse the question and step back a lot. How do I start?
Before that, I think there's probably a question.
Yes, a
that we
question.
may
Thank you,
want to-
Abby.
Hey, Xavier, Nabi, thank you. Yeah, so this is another really good question that I think might there might be some clarification here that you guys can help out the audience with. But the question was by Frank that says, does the TTI join server generate the keys from manifest IDs, or have the keys been pre-shared between Microchip's manufacturing and TTI, and they just get looked up by the manifest ID?
The keys get generated by the identifier, so there is no transfer of a whole lot of device keys from Microchip to us,
Yes.
because that would make it really challenging and actually insecure to because then you start transferring device keys.
Yes.
So we don't do that. So what we do is we both have an HSM, and we did a secure key exchange for a pre-shared master key, from which we can derive the same root keys. So that key derivation happens on Microchip side in the secure facility, where the ECC device gets produced, and on our side in the join server, where every time, it's not even when the device gets claimed that we generate all the keys, because then we need to store all the keys in the cloud. We don't do that. But every time the device gets activated, that is when we generate the root key for that end device.
Okay.
That's a good question.
Yep.
Great. And when you say HSM, can you just clarify what that is for?
So that is a hardware secure module. So
Okay.
that is a physical device that is designed for keeping keys safe, but also performing cryptographic operations without exposing the root key. So you can basically request to the HSM, encrypt this or sign this, and then you get the encrypted version back or the signature back without normally doing this in memory. Requires you to have the key in the clear in memory, and that makes it already unsafe.
Yeah. So HSM, it's a fancy big, computer or processor with the data that is stored in a secure way, in very basic terms. And the key point is that the keys are stored securely. There is FIPS and common criteria certified. So these are the ones that are used typically for smart cards and even many other applications that are dealing with secure provisioning.
What does it, can you give us a visual picture? How does it look like? Because when you hear device, I think people might think it's just a board.
No, so the ones we have, they are, they go into a server racks and they cost about, each one is $50,000 or something like that. And again, those are within a secure facility with cameras, 24/7 auditing, monitoring, and access controlled. And that is where the very one time we did the key exchange in a secure manner also, where nobody in Microchip would have any knowledge of that pre-master key, and that would be loaded into the HSM, and that is what will be used in conjunction with these identifiers to generate the root keys per device.
Okay.
And that's exactly the same way that they would do.
Yeah.
I mean, at the end of the day, symmetric key means two sides have to share the key.
Yeah.
There is no other way for you to do that, and this is the way that we take care of it from a logistics point of view.
I like how simple you make things.
I also have a question to Abi. So I have a cloud background, right? So when we talk about these devices, because a great question is, what does the HSM look like? What does the ECC look like?
That's a very good question. So ECC,
What-
ECC608A is a secure element. Shrink that $50,000 big computer into an extremely small set of device, and that can support a small embedded device with the same level of security for certain keys. So 608, think of it as for every device you have the small mini HSM that is being shipped around that does the same job of storing the key properly, so that nobody can get into it.
But how small is it? Is it like a SIM card, or is it?
It's
much
2
smaller,
by
right?
3. 2 by 3. It's like
2 by 3
Millimeters.
millimeters.
Okay,
Yeah, it's
right.
like extremely small.
And what else can you do with it?
So there are a lot of other use cases that customers use with secure elements. LoRa is one of it, and we can do with the same pre-provisioned TTI chip. Customers, if they want to still connect to a cloud, they can do that because the devices come with a set of private keys and certificates that customers can also connect to, let's say, the choice of AWS or Azure or Google or any other cloud, along with TTI.
Yeah.
And they can also do secure boot. I could provision the device in such a way that my firmware, every time it boots up, it makes sure that the firmware is authentic before I even start executing the LoRa. So secure element comes with a lot of opportunities for customers to really take advantage of various use cases.
Right. Yeah.
Okay, so we had a pretty long discussion on the concept, and like I said, how do I start? What's my first step?
It's, that's a good question. So what I would say is maybe if you can go to the slide. So we do have a website or URL that is listed on the top that has all the details. But as mentioned earlier in the giveaway topic, we have a SAMR34, which is a system in package. That's a low power 32-bit microcontroller with the LoRa transceiver. And we also have the socket board that helps you to put a pre-provisioned secure element and connect it to the main board. And the part numbers are listed below that you can order to be able to take advantage of from the hardware perspective. And we also provide software stacks. So we provide not only Microchip's Microchip developed LoRaWAN stack that comes with support on secure element, 608A secure element, and you can just plug that in and go through the steps for connecting to the TTI joint service.
Mm-hmm. Okay. So, what do you guys offer?
Yeah, so on the network side, to complete this whole story is that you need to have a gateway. So we have these. These are $69 per unit. But there's also a lot of industrial gateways that you can put outside to provide coverage. They all work on TTN. And we have our conference. So we run quite a few conferences this year. So we start in the UK, then we go to India. I will be going there myself, and also to Australia. And then we have our big show in Amsterdam. We will all be there, also explaining more about the secure solution. And then we go next year to China and Slovenia. And this is where you can learn about LoRaWAN, about security. It's really a LoRaWAN developers conference, but security is really at the core of many solutions.
Right. I want you to tell us more about that generic node.
Yeah, this is our other product. So this is a device that has around it has 9 sensors, and that allows you to build 20 to 30 different use cases just with this device. And the nice thing about it features, of course, the secure element. So we set the example of building a secure device. It also features the SAMR35. That's the Microchip system in a package, a low power LoRaWAN. But we also allow over-the-air updates. So this is also where secure boot comes in. This means that you can buy the device, you can just turn it into a desk presence sensor, you can use it for cold chain, you can do many things with this particular device. Okay. And this comes at a price point of
Microchip or from ARM. Now I'm starting to develop, if I want to quick start everything, I'd probably use your generic node, and then I've got sensors all around. Buy your gateway, now I've got my gateway, open up my network application, so join servers, and that should be in pretty good shape to get started. Okay, cool. Matt, I think you have a few words for viewers.
Yeah, absolutely, Xavier. Thank you. So, like I said, you guys have had some great questions today. We have some cheering for Johan to come out to Masters next year, so maybe he'll have to make that happen. But you guys did a great job, so really appreciative of that. I think there was one more clarifying question that I was going to ask, which I guess, where did it go? Jeez, I'm blanking now, of course.
That's okay.
But I think the concept of just how do I get a key, what is a key, how do I start working with keys, whether or not I'm actually using a join server, has been kind of a consistent question that we've gotten. There's been a lot of questions related to keys. So with that information specifically, is there some place that users can go to get more information if they're kind of looking to get started with that aspect of security?
So what I would say is we have a whole getting started on how to get the hardware set up and also how to connect to the TTI join service on GitHub. If you go to the GitHub CryptoAuth lib, we will provide more details probably in the comment section below. And there we have a step-by-step guide. And really from a key point of view, or the keys generation and provisioning point of view, we kind of took that burden onto ourselves so that the developers don't have to really worry about it anymore. So the quick answer to that is you probably don't really have to even worry about the keys or how to generate the keys or how to provision the keys or how to transfer the keys. We have already taken care of it, and all you have to do is as simple as what Xavier mentioned. Get the part. You already have a file that you can download. TTI provides you the instructions of how you can claim the devices by uploading it, and that's it. Magic happens in the background, and the device knows exactly how to talk to the cloud.
Great, sounds good. Yeah, I know we always used to joke about how all of engineering is just kind of black magic if you go deep enough. So that's exciting to hear that I don't have to worry about learning that. So we have some winners, like we said, and obviously there's been a lot of great communication, and unfortunately we cannot give a free board to everyone this time around. But the 5 winners for today, and before I get started, make sure that when you email us with your name, your phone number, your full address, and
I believe
that's
that's
everything.
Yeah.
I think that's everything.
And we apologize in advance if we cannot ship to your country, but
yes,
we'll do
we have run into that in the past, so we will do our best though to make sure that you get the free stuff. And you're going to email the live stream at microchip.com, and we usually get those shipped out within the first couple weeks after the live stream. So yeah, we'll get those things to you as quickly as possible. But the 5 winners are Isaac Rose, Demetrius Giacomis. I apologize if I said that wrong.
You did good.
Paul Hayes, Frank Rose, and Dick Mincher. So once again, that was Isaac Rose, Demetrius Giacomis, Paul Hayes, Frank Rose, and Dick Mincher. So congratulations, guys. Thank you for your awesome questions. If you didn't win a prize this time, all the more reason to come back next time.
Exactly.
Next month it'll be it's like the 2nd or 3rd week of October. You can check online at our microchip.com/live stream. We'll have that posted here in the next couple weeks, but we're going to be talking about graphics. So we're bringing in our 32-bit team to kind of have a basic presentation on, I've got an LCD screen, what do I do with it, kind of an idea. So make sure you don't want to miss that. It's going to be great. I'm excited. I'm already learning stuff as we begin to prepare for it.
I'll be there.
Clifford will obviously be there. You'll get to see his happy smile and great hair. So make sure you don't miss that. All right. Well, with that note, make sure that you all subscribe if you haven't already.
Yep.
That's how we make sure that we can continue to get you guys updated and informed about our live streams. That's probably the easiest way possible. You can also jump on to microchip.com/live stream, and you can sign up to be part of our email chain specifically for live streams. That way, we send out a lot of good content, and sometimes it's hard to.
And even if you guys subscribe, don't forget to hit the bell notification.
Right,
Because that's how you actually get notified when we're about to go live, so you can interact live with our engineers or our wonderful guests like Johan.
Yep, exactly. Well, I think that pretty much covers it from our end. Xavier, you want to take it home?
Yeah, sure. Abhi, I know your time is precious. Thank you very much for allocating some time. Johan, you travel, 2 continents, 1 ocean, just for this live stream, and a few other meetings. So thank you very much for both of you. And we will see you in the next live stream. Thank you very much.